This is the lesson on static electricity, and it's for the triple science students only. So I'd like to have a look at some static electricity experiments. You could either try some at home or watch them on YouTube and think about what is happening and why it's happening. And that's what we're going to address in the lesson today. We already know from our lessons on forces that like charges repel and unlike charges attract. This diagram represents a piece of insulated wire. So you've got the brown copper running through the middle and the green insulating wire on the outside, which is obviously made of plastic. In insulators like plastic, charged particles can't move. So we say that they are static. Remember, static means still or unable to move. This means that the charges are stuck in one place. However, we know in conductors, such as metals, that charged particles can move. That's why we can get a current flowing through a metal, but we can't get a current flowing through something like plastic. An insulator becomes charged when it's rubbed, but you always need the force of friction in order to build up static electricity. It's the electrons that move from one material to another. Remember, in metals, electrons are free, and that's why they can flow as a current. Although they're not free as such in insulators, they can still be moved from one material to the other. Depends on the material which way the electrons will go. Looking at the top left diagram there, the electrons are going to go from the cloth to the negative rod. On the other side, the electrons are going from the rod, which is perspex, onto the cloth, so the cloth becomes negative. Either way, it's always the electrons that move. The Van de Graaff generator is a practical you often see in the lab at school. And I've also shown it on some of the video clips I've chosen for you to look at the end of this presentation. The electrons get transferred onto the belt, and the belt takes them up to the metal dome at the top. Here they build up. You keep adding more and more and more electrons on that metal dome. But of course, electrons are all negative, so they start to repel each other because they have the same charge. Eventually, there are a lot of electrons all crowded together and yet trying to push each other away. And so they repel each other and eventually have enough energy that they escape, jumping from the dome onto the metal ball across the gap, and that causes a spark. Another example you ought to be able to talk about is how static electricity builds up as we walk across a floor, for example, on a nylon carpet. Here, my little man's going to walk across the carpet. As he does so, in this example, the electrons are transferred to his feet. Therefore, his body becomes negatively charged and the ground below him is slightly positively charged. As he holds out his hand to the door, the negative charges in his body are going to repel the negative charges in the door. They move away easily because the handle is metal and therefore a conductor. The negative charges in the man's body are now attracted to the positively charged handle of the door. They're now going to try and jump the gap. If the gap gets small enough, the charges will have enough energy to jump across. It is as the charges jump the gap that a spark happens, and that's what happens when you get an electric shock. Here are some videos that I would recommend to have a look at about static electricity. There's only one lesson in the course, but some of the questions that come up in exams can be very long. Scientific Eye is very good because it gets through the basics in a lot of depth and really helps you understand them. I like the Science Shack video because it gives you some applications, and if you like watching somebody try to electrocute themselves with 1,000,000 volts, then it's the one to watch. And then Brainiac is just a bit silly at the end. Have a look though, it's quite a good example of an application of static electricity. Good luck.